Today we're going to learn section 4.8 of your BJU Press Precalculus textbook. Now that we've learned logarithmic functions, we're going to learn how to apply them using word problems. So there's different types of logarithmic applications that we can do. They include chemistry, physics, and education, and financing. And then we're going to also, for the financing, we're going to look at compound interest and how it relates to exponential growth. So the first thing we want to look at is an application for science. So when we have earthquakes, we want to measure the earthquake intensity. We do that using the Richter scale, and that's what seismologists use to measure the intensity of an earthquake. So earthquake intensity, which is represented by M, is this formula. M equals log of L over L, and then that little zero is kind of like L naught, so L over L naught. So M is the Richter scale value, so that's the intensity that you're trying to find, or the Richter scale value, and you use that using L, or I guess. So L is the intensity of the earthquake, and I naught, or L naught, is the standard minimum intensity. So for example, we have an earthquake that has an intensity reading of 10 to the 7.5 times that of L naught, or the standard minimum intensity. What is the measurement of this earthquake on the Richter scale? So we know what we're trying to find M. So we have log of 10 to the 7.5 times L naught over L naught. So the L naughts cancel. So now we have log of 10 to the 7.5. So log of 10 to the 7.5. Well, the 7.5, if we use the power rule, that's 7.5 times log 10. And remember, log 10 is 1. So 7.5 times 1 is 7.5. The next application we can use the log function for is chemistry, and that's when we're trying to find the pH of a substance. So pH measurement is equal to the negative log of the hydrogen concentration. So this little bracket with the H plus, that's the hydrogen ion concentration of the substance in moles per liter. So if we have a pH, if we want to find the pH of milk, when we know that the hydrogen ion concentration is 4 times 10 to the negative 7, we would plug that into our formula. So negative log of 4 times 10 to the negative 7. And we can use our log properties. This is the multiplication property, so it becomes negative log 4 plus log 10 to the negative 7. And then log 10, of course, that cancels and becomes 1, leaving us just the negative 7. So now we have negative times log 4 plus negative 7, which gives us approximately 6.4 on the pH scale. So the pH of milk is 6.4. So in education, there is a formula for forgetting curves. So this comes from the idea that the longer you go after you test on information, the further from that test, the more that you forget. So this is the average test score on previously learned material is A minus B log of T plus 1. So T is the time in months since you've first tested on the material, so T is the time in months, and A and B are going to be constants that are already given to you. So for this example, let's say we have an average score in a geometry class for a certain exam is given by the function S of t equals 73 minus 12 log of t plus 1. And remember, the t is time in months. What was the original average score? Okay, and then what will the average score be on the same exam a year later? So the original is when t equals 0, right? Because no months have gone by. So we'll plug in 0 for t. So we get 73 minus 12 times 0, or just 73. Now we'll do a year later. So 12 months have gone by. So we're going to plug in 12 for t. And then, so we have 73 minus 12 log of 13, which gives us approximately 59.63. So this says is if the original average score was a 73, 1 year later, the average score on the same exam would be 59.63. So let's say an average score in a geometry class is given by 78 minus 15 log of t plus 1. What was the original average score? So remember, original is when you let t be 0. So there you go. What would the average score be after 5 years? So after 5 years, that's 60 months, okay? So we'll plug in 60 for t, and then we get approximately 51.2. So our next application of log function is doing the continuously compounding interest. So we talked about compound interest, and so you can compound, once a year, twice a year, monthly, whatever. But let's say you're compounding all the time, like continuously, like every half second. So to do that, you can't just use anything for n because you're constantly compounding. So we get a new formula. It's going to be P times e to the RT, where A is the total amount, R is going to be the annual interest rate, and T is the time in years. So let's say we have $400 deposited in a savings account with an interest rate of 6% for 42 years. How much money will we get at the end of 42 years if it's compounded continuously? So we're going to use our formula. So 400 is our principal amount. Our rate was 6%. That's where the 0.06 came from. And then it was 42 years, which is where the 42 came from. So if I plug that into my calculator, I'm going to get $4,971.44. Last question. How long will it take Shannon to save $800 if she has an initial investment of $430 at 5.5%? So for this one, we're trying to solve for t. So we'll plug in the information that we know. So we know that she wants to get 800. So we know it's supposed to be equal to 800. Her principal amount was 430. This was the rate, and we're trying to solve for t. So the first thing we'll do is we'll divide both sides by 430. And then we're going to take the ln of both sides to cancel out the e. So now I have that the ln of 1.86, the 1.86 came from the 800 divided by 430, equals 0.055t. So I'll divide both sides by 0.055, and then the time is an approximately 11.3 years. All right, go ahead and try some problems on your own.